So what is electromagnetic wave? If we try to define it, we will say it is a definition is it is a coupled time varying electric field and magnetic field which propagates in space. It is a coupled. Coupled means they are linked to each other. If one vary, then other must vary. Then we will see the properties, how they are related, their variations are related. They say if they are the fluctuations of electric field and magnetic field which are time varying and coupled with each other. So the proper definition is it is a coupled time varying electric field and magnetic field which propagates in space and transfer energy and momentum. That is called electromagnetic wave. Electric field and magnetic field vectors are perpendicular to each other. This is one such property. Electric field and magnetic field are perpendicular to each other. Both are perpendicular to the direction of wave. That means they both are perpendicular to the, if wave is traveling in this direction, this is the velocity of wave. So electric field, magnetic field and velocity of wave both are, or you can say all three are perpendicular to each other. You can do like this. Clear? They all three are perpendicular to each other. That is one such property. Because of this perpendicularity, they are known as transverse wave. That means oscillations or fluctuations of electric field or magnetic field is perpendicular to the motion of wave. If such a motion is happen, this such type of waves are known as transverse wave. Clear? So these are the basic property. We will see the other properties also, and then we will move forward with the equations of electromagnetic wave. Clear? So let's move to next part. The next property is they do not require any medium for their propagation. Just like mechanical wave, string wave, sound wave, they require medium particles for their propagation. Electromagnetic waves are such waves which can travel in vacuum because they are the fluctuations of electric field and magnetic field. So no medium particle got disturbed. It's just a electric field is fluctuating and electric field is decreasing, increasing, decreasing. So what is happening? So they do not disturb any medium particle. They do not require any medium particle for their propagation. These waves do not get deflected by external electric field or magnetic field. If you say there is an electric wave which is propagating, and if you apply some external field or some external magnetic field or some magnets, so they will not be able to deflect it. Clear? So they are not deflected by anything because they are not charged now. They are not charged particles. They are just fluctuations of electric field and magnetic field. Charged particle can be deflected by external electric field. Charged particle can be deflected by external magnetic field. But electromagnetic waves are not charged particles. They are produced by a charged particle, but they are just the fluctuations of electric field strength or magnetic field strength. EM wave carry both energy and momentum. They transfer energy and momentum. That's why that they satisfy the property of wave, definition of wave, and they are in same phase. Same phase means they are increasing at the same time and they are decreasing at the same time. They are maximum at the same time, they are minimum at the same time. They are negative at the same time, they are negative minimum at the same time. So that's why they are in same phase. 0 together, maximum together, negative maximum together, again 0 together. So they are in same phase. And in phase also, mathematically we will see what do you mean by phase in few minutes. So let me revise it once. What is transverse wave? Where motion of particle and wave motions are what? Perpendicular to each other. That is called transverse wave. And here longitudinal wave, velocity of wave and motion of particle both are parallel to each other. That is called longitudinal wave. This is the example of sound wave and this is the example of transverse waves in string. So both these are the example of two nature of waves. So what is happening? Particle motion is perpendicular to wave motion. This is one such property. It can travel both in vacuum or in medium. That is one the case. And here what is happening? Particle motion is parallel to the motion. That is the most important property of longitudinal wave. That is, they require medium and they do not require medium. They can they both can be traveled in vacuum and both can travel in medium also, but motion is at 90-degree, motion is parallel. Clear? That is the main property. Let's move towards the what is the equation, mathematical equation of electromagnetic wave, and what kind of question they ask from this chapter. Clear? So let's move to next part. Equation of wave. So any general wave is of this type, plane progressive general wave. So let's see what are the wave parameters in this equation. Mathematically, wave is defined as it is a function of position and time, that is x and time, which travels in space and carries energy and momentum, but it must be finite everywhere. It cannot be infinite or not defined at any point of x or t. Clear? It must be defined everywhere. So A is what, K is what, omega is what, phi is what, or so these are called wave parameters. So we will see what are the wave parameters in this direction, in this equation. So A is called amplitude. We all know because we have studied SHM also in previous classes, or we have studied motion of mechanical waves also. So it is this distance from the mean position, maximum distance from the mean position is amplitude. K is called wave number, number of radians per unit length. K is called wave number. We will define what is K. Wavelength lambda. Lambda is what? Distance between two consecutive crests or two consecutive troughs. That is, this one is lambda. Two consecutive maxima or two consecutive minima. This is called wavelength. Then time period is the time of oscillation of particle. The particles are oscillating. Here electric field is oscillating. So electric field is 0, then it will become maximum, then 0, then negative, then 0. So if it is maximum at certain instant, then after how much time it will become maximum again. So that is the time period. It is time taken to complete one oscillation. It may be by a particle or it may be by a electric field or magnetic field. Clear? So frequency is defined as number of oscillations per unit time. That is, frequency is 1 by t. Angular frequency omega, it is 2 pi by time period or 2 pi f. This formula we already know. Phase constant is phi. It is the description how displace the wave from the original position. Phase constant, this is called phase constant phi, and this total term is called phase. This total term is called phase. Phase is a function. Phase is what? This is kx plus minus omega t plus minus phi. This is called phase. Phase is a mathematical function and this is a phase constant. This gives you some information about how originally the particle was displaced when we try to study at it equal to x equal to 0 or t equal to 0. So it gives you some information about its initial position. Then speed of the wave is lambda f. Speed of the wave is lambda f, or it can also be written as omega by k. So the two main thing is, one thing is k. K gives you information about lambda. So k is nothing but 2 pi by lambda. K is given by 2 pi by lambda, one thing. And then omega. Omega is what? 2 pi by time period. It gives the information about frequency and time period. So these are the two important equation, and ratio of these two, omega by k, this also gives you velocity, or lambda into frequency, it is also velocity, omega by k, it is also speed of wave. So these are the basic parameters which we have already covered in our previous chapters. So we were just revising it. But for electromagnetic waves, how they will be defined? So see, for electromagnetic waves, if you see for electric field is defined as what is the maximum value? E naught sine kx, x traveling along positive x, so minus sine omega t. Clear? So this is something like Ey, y axis. So it is fluctuating along y axis, and this fluctuation is given by Ey equal to sine kx minus omega t. So you can write k you can put here, omega you can put here, or you can take something common. So these are the other form, but this is the standard form that you can write. Okay. And yes, other things are, this is the third axis, so it must be perpendicular to x and perpendicular to this also, so it must be bz. So what is bz? B naught sine kx minus omega t. So bz is, you can put the value of this and then simplify it further if you want, but I think this must be sufficient, and here this must be sufficient to gauge what is the equation. Clear? So these two equations are important. They are perpendicular to each other. So actually what is happening? So electric field is propagating, fluctuating in this direction, and magnetic field is fluctuating in perpendicular direction. This is, and both are perpendicular to each other. Both are perpendicular to each other. This is x, this is y, this is z. Clear? Fine. So these are the equations of electric field and magnetic field. One more thing, that what is the velocity direction? Velocity is perpendicular to this. So one thing you can note down, that velocity direction v vector is always parallel to E cross B, not equal to E cross B, but parallel to E cross B vector. So V vector and E cross B vector both are parallel to each other. So velocity of wave is always such that it is parallel to E cross B. How you will find E cross B? This is your E, electric field vector. This is your magnetic field vector. So if you do E cross B from Y axis, you try to curl your right hand finger towards Z axis, then X axis will give you the direction of what? X axis will give you the direction of V. So V is in this direction. So this rule you must remember for velocity direction. Clear? And one more thing that I want to convey, direction of electromagnetic wave. Yes, the same thing that I conveyed. Electric field and perpendicular to each other, and what I want to write, V vector is parallel to E cross B. One thing, this is for direction. This is for direction of electromagnetic wave. And magnitude, relation between peak value of electric field and this. Peak value E naught by B naught is always equal to speed of light or speed of EM wave. You can write this is speed of EM wave or light. Light is also an electromagnetic wave, so you can just write this. So there is a famous equation, E naught is given as B naught into C. C is speed of light. This is C. Clear? Velocity vector is nothing but C vector, speed of light. So this is one such equation which you will write, E naught by B naught equal to C, and the one is velocity vector is parallel to E cross B. So these two things are important, which we will see in question, like how to apply these concepts in question. Once we will do the question, so you will be comfortable with how to use this value and how to use this direction information. Clear? Then velocity, speed of light have one more formula, which is in term of permittivity and permeability of medium. What is this? Speed of light in vacuum is nothing but given by 1 upon mu naught epsilon naught. If you find this value, this is the value which comes out to be 3 into 10 power 8 meter per second. Speed of light in vacuum is given by 1 upon mu naught upon epsilon naught. So what is the speed of light in medium? What is the speed of light in medium? In other medium you will write mu of medium and mu of epsilon of medium. Then refractive index of a medium can be defined as speed of light in air, speed of light in medium. They are inversely proportional. So this will go something like this. So refractive index can be written as relative permeability into relative permittivity, and this relative permeability is nothing but sometimes it is also called dielectric constant. Sometimes we call it dielectric constant K. Clear? So this is the value of refractive index mu r epsilon r. So what are the takeaway? What are the key takeaway if I write? Key takeaway is speed of light can be written as lambda into f. It can be written as omega by k. It can be written as E naught by B naught. E naught by B naught. It can also be written as, for vacuum it can be written as this. It can also be written as mu of medium upon epsilon of medium, or it can also be written as, for medium it can also be written as speed of light is divided by refractive index n. Like these are the formulas that you can write. This is for speed in medium and this is for speed in air, and these are general. So these are the terms, and direction is parallel to E cross B. So these are the various formula, any of the formula you can use. Refractive index is what? Refractive index is given by this formula. This also you try to remember it. Clear? So if you think you are having a torch, so if whenever you are lighting this torch, so what is happening? There is a light which is coming out of it, but actually it is a fluctuation of electric field and magnetic field that is coming out of it. It is disturbing. This disturbance is propagating through the space. Clear? Yes. So we will do question next and then we will try to apply this. So let's move to next part. Let's see some question based on these concepts. Let's start with this question. In this question they are asking if frequency of electromagnetic wave is this. They have given a frequency. They are giving me this is the frequency of electromagnetic wave and it travels in air along z direction. Then the corresponding value of electric field and magnetic field vectors will be mutually perpendicular to each other and the wavelength of the wave would be. For this wave, what would be the wavelength? This is moving along positive z direction. So equation is not given but some frequency is given and they are asking me. So we know one formula, lambda into f is nothing but speed of wave. And for air what would be the speed? What would be the speed? C. So for air it would be 3 into 10 power 8. Lambda we need to find out. And what is 60 megahertz? This means frequency would be 60 into 10 power 6. So this would be the working equation. If you solve it, you will get the result. So what you can get here, only 2 will be left. So what you will get here, you will get 300 upon 60. So what is the answer? Lambda is 5 meter. In meters it would be 5. I think C is the answer. So this question was very easy. Okay, so we have previously solved such type of question in wave mechanics also, in sound wave also. In class 9th also this was a simple formula which we used to solve question for. Then let's see one more question based on electromagnetic wave. It is saying a plane electromagnetic wave of frequency, this is again frequency is given in free space, this means speed is c, in x direction. Then they are saying at a particular point in space, at a particular time, the electric field is given by this J cap and this much voltmeter. The value of electric field would be this. Then the corresponding value of magnetic field vector would be. one thing is the direction. See the direction, how it would be. Suppose this is your x-axis, this is your y-axis, this is your z-axis. So electric field is present along z-axis and it is moving along. So this wave is traveling along x-axis and electric field vector is along, this is your electric field vector. So we know E cross B would be parallel to, E cross B is parallel to velocity vector. What is this? This is J. Cross, we don't know what is this value. It must be parallel to, what is this? I cap. So then this value should be J cross what? J cross what becomes I cap? So J cross K becomes I cap. That simply means magnetic field must lie along Z axis. Magnetic field must lie along Z axis so that this complete wave travels in Z. So this would be your B vector. So E cross B, if you see right hand thumb rule, E cross B would be along X axis. Clear? So direction is clear that it must be along K cap. Now, so this option is rejected because of the direction. This option is also rejected because of the direction. What is the magnitude? If I go for magnitude, so you will say, sir, electric field magnitude would be what? E naught equal to B naught times C. So what is B naught? B naught is nothing but E naught by C. This is the magnitude formula. So we can calculate what is B naught. E naught is given, electric field at any point in space would be 9.6 and divided by 3 into 10 power 8. So what you will get? 3.2 into 10 power minus 8. So this would be the unit, Tesla. This much Tesla would be the magnetic field value and its direction will be along, what is this value? The direction of B would be along K cap. So which option is correct? I think it is 9.6 and here it is 3.2. So this option would be correct. So this option would be correct. It is also given here that answer A is correct. Clear? So this is how you will try to attempt. One thing, this is very, very important. Like many of the times question has been asked based on the direction. You just need to keep in mind the direction of E cross B, the direction. If this is E, so E cross B, wherever the B is, that will be the direction of E cross B will match with direction of velocity. That you need to keep in mind. Clear? Now see one more question. Let's see this question. So they are saying electric field in electromagnetic space free space is represented by this equation. That means its amplitude is E naught. This is the phase. It is moving along what? It is moving along Z axis plus Z axis, and this is the direction of electric field. That is, electric field fluctuation is along what? I cap. Now they are asking the corresponding magnetic field vector would be. See, if you again draw the same diagram, it would be X, Y and Z. So now this time it is moving along what direction? It is moving along plus Z direction. So and E vector is along X axis. So that is this. This is the meaning. Electric field is along X axis. Velocity of the wave would be along V direction. That is the meaning. Here minus sign. So it means plus Z axis motion. That is the simple meaning. Plus Z axis motion. Motion of the wave is along plus Z axis. So this is the electric field value in this direction. Now they want you to understand, find the value of B vector. So what is B naught? One thing is you can write it is E naught by C. The amplitude of would be E naught by C. So this option would be rejected, this option would be rejected, because here you will find E naught by C and here also E naught by C. Then one thing, the phase remains same, phase remains same. Yeah, this is the phase remains same, here the phase changes, so it is not the correct answer. So the correct answer would be option number B. How you will justify here? So E cross B would be what? E cross B would be, so B vector should be plus. So you will say that X cross, X is what? I cap. So I cap cross J cap, it will be parallel to K cap. So this would be the direction. This is E vector direction. So this would be the direction of B vector, J cap. So this would be the supposed representation of the wave. A rough representation would be something like this. The wave would travel along Z axis, where fluctuation of magnetic field would be in YZ plane and fluctuations of electric field would be in XZ plane. Clear? So that is the simple meaning. Clear? So I hope you understand ki how we are able to eliminate the other options and how we are able to tick this option. Clear? Let's move to next question. So read this question. The magnetic field of electromagnetic wave is given by this. This is the value, sin 30 and this value. Now they are asking you the corresponding electric field value would be. The corresponding electric field value would be. So one thing you will write that sir, the E naught would be what? B naught times C. B naught into C. So this is your what? This is the direction of what? Magnetic field. And now we need to find the direction of electric field vector. So one thing, let us start with the phase and other analysis. So we will first say this sine function will remain same. So if you look at all the options carefully, this option is having a cos function, so it cannot be the electric field value because of the cos function. So sine function should remain same, even the phase value must remain same. Two things shall be clear. Then the phase is what? This phase, the argument of sine, that must also remain same. This phase of both B vector or E vector, that must be same for both. So if you carefully look at all the option, this phase is different, so it is not the correct answer. This phase is different, so it is not the correct answer. So this phase is same. So can you say this is the correct answer? So answer would be A. You can easily eliminate. One thing, so this portion must remain same. If you see, this portion must remain same. Clear? So it is same. Now one more thing, where is C? C is slightly, it is written here. Where is B naught? B naught is this value. But why there is a difference here? Why there is a difference? Yes, there would be difference because B naught is different vector and E naught is different vector. Clear? So by eliminating this thing, so you can eliminate this and this would be B naught times C. This would be the final vector. Clear? So please look at the options carefully whenever they give you some typical or some difficult equations in the form of electric field or magnetic field, and you want to find the equations of the different electric field or maybe magnetic field. Clear? So both the cases you will try to remember these steps. Now there comes a topic which we call as energy density. Energy density of electric field, energy density of electric field, energy density of magnetic field, and total energy density of electromagnetic wave. We know every wave carry energy and momentum. Every wave carries both energy and momentum, and they transfer both energy and momentum from one place to another place. Clear? The wave is a function, mathematical function, which is definite at every point, and it must carry energy and momentum, and it must transfer both energy and momentum while it propagates from one point to another point in space. That is the simple definition. So, here the energy is travelling in the form of electric field or magnetic field. Some energy is stored in the form of electric field, and some portion of the energy got stored in the form of magnetic field. And both these energies values are equal also, like 50% gets stored in the form of electric field and 50% gets stored in the form of magnetic field. Clear? So, here we are studying energy density of electric field. What is the energy density of electric field? So, we will see two scenario, like there is a capacitor, it is just a case, but it is generalized also. For capacitor, we can easily look at the calculations because we already know the formulas, but that the outcome result is not just limited to capacitor, it is valid for all kind of electric field in space, whether uniform or non-uniform. Clear? So, see, if you have a charge capacitor plus Q charge, A epsilon naught by D is the capacitance, and electric field between the space is given by this. So, you know the energy is half CV square, and you also know the potential difference can be written as E into D, because E is what? V by D. This you can write, and electric field is nothing but V by D, delta V by delta R. So, once we are able to write this, then we can use this also, V equal to E by D. So, if you put the value here and C value also, so you will get half of epsilon naught E square AD. So, if you closely look at this, AD value is what? A into D. Area of the plate, this is the area of the plate, this is the area of the plate, and D is the separation. So, this is the volume. This is the volume of capacitor. So, the total energy stored between the plates of capacitor is half of epsilon naught into electric field square into volume. If you find energy density, this is called energy density, energy per unit volume. This value would be what? Half of epsilon naught E square. And this E is what? This E is the constant value, uniform electric field. Or you can say RMS value. RMS value is again, it is a constant value. Okay? So, you can note it down that whenever energy density is written for a uniform electric field, it would be what? Half epsilon naught E RMS square. Clear? But what if the field itself is variable? Then how you will write? Let us see that. If the field is variable, suppose this is a not constant field but variable field, then ERMS can be written as E naught by root 2. E naught by root 2. Then you will get energy density here, mu E we will write, or small u E generally what you wrote, not mu, it is just small u. Clear? So, small e is equal to half of epsilon naught this square, and what is the average value for this? Average value is half. Average value of sine square function would be, for a one cycle it would be half. So, you will get in terms of peak value, you will get this energy density UE, small u E, it would be what? Half epsilon naught E naught square. Clear? So, that is the energy density. This formula half of epsilon naught E square, it is for RMS value, and this formula is for peak value. If it is written in the terms of peak value, 1 by 4 epsilon naught E square. So, this is itself is a 50% of total energy. This value is 50% of total energy density. Total energy density. That means total energy density would be what? Double of this. Total energy density would be double of this, because this value itself is a 50%. Clear? Now, if you look at energy density of magnetic field, so again, what similar way you will be able to find energy density of the magnetic field would be 1 by 4 E naught B naught square. Clear? What you got? Suppose there is a magnetic field inside an inductor. So you can write energy of inductor is half Li square. What is L? Mu naught N square Li. And what is I? B upon mu naught N. Because B inside is mu naught Ni. So from there I calculate and L can be calculated, and from here I can be put into this. So if you put both the values, so this value will become what? Volume. Area into length, it will become volume. So energy per unit volume for a magnetic field, it would be what? Half mu naught B naught square. Or in terms of RMS value, if you write, this is what? RMS or constant value. If it is not variable, then this would be the case. In terms of variable field or peak, where we need to use peak value for a sine square function, it will be 1 by 4 epsilon naught B naught square. Or in terms of this, you can write, there is a correction, I think. It would be mu naught here, na? Yeah, 1 by 4 mu naught only. Just make a correction here. Just make a correction. So I'll correct it. It would not be the case. It would be half of epsilon naught. Yes. So you would be able to correct it. It would be 1 by 4 mu naught. So this value I can write it here again. So energy density of magnetic field, it would be 1 by 4 times 1 by 4 times B naught square upon mu naught. This is again what? This value is energy density of magnetic field, variable magnetic field, but this is again 50% of total. 50% of total. That means total is again double of this. So if I need to summarize all of this, so the total energy density is part of what? Mu E and mu, UE plus UB. That means, and these two both are equal. Both are equal. That means 50% here and 50% here. Energy is stored in both these forms, UE, UB. Energy density of electric field, energy density of magnetic field equally shared between them. And if you write total energy density, you can write twice of UE, which would be what? Total energy density, it would be half epsilon naught this. And what is this value? It is nothing but U by volume. That is the meaning. Total energy stored in the form of electric plus magnetic field divided by the region, volume. Clear? So this is small u, this is small u, this is denoted by small u actually. That is the case. So you will, I think there is some, yeah. So you can just correct it. This is small b. So here you will get this value, this value. So if I try to conclude U total. So either you can write it half of epsilon naught E naught square, one thing, or you can write it half of B naught square by mu naught. This is U total. Any of these formula can be used. This is the summary you can remember. This is energy density of electric field is one half of this. That means 1/4 epsilon naught E naught square. This is the value. Energy density of magnetic field is what? 1 by 4 B naught square upon mu naught. Clear? That is the energy density value. These are the energy density for a variable electric field or variable magnetic field which are varying as per the sinusoidal or sine or cosine function, you can ask. Okay. There should be some harmonic function which will follow the oscillations. Clear?